Okay, so mapping the pitch circle to the color circle. So each note, so once we have this mapped out, then I can derive an exact color, and we'll use help from like a ChatGPT and our color system to do this. Now note, we kind of cheat a little bit here, because as we saw, the color spectrum should be going, you would think, from the purplish color to the red, and we basically, as artists, the artists make it go the other way. So we start with longer wavelengths, and then we go to the shorter wavelengths. So you can see we're going from longer wavelengths are red, and then it's going around the circle. We bent it into a circle. That's what you would expect. It's just going from longer to shorter. And then over here, you might say, whoa, what happened right here? That wasn't on the spectrum. This bit wasn't on the spectrum, because we started with a sharp purple, and then it went to red. So you would think if you bent the thing into a circle, you should have the purple right adjunct or at 11 o'clock going into red. But that doesn't blend well, right? So what do the color people want to do? What do the artists want to do? They come up with a mixed color that's not actually being measured by light. So what happened here, from a scientific perspective, we can measure light from short wavelengths to long wavelengths, and then it's just a spectrum. And if you could bend it into a wheel, but you'd have this basic thing, this jarring thing of it going from purple to red. So the artists said, no, we like in our human realm it to go from warm to cool, and we see purple as cool, even though a purple flame is hotter than a red flame. But in human realm, we think about color and what we draw from warm to cool. I think that's basically what happened, right? And I don't want this jarring thing going back. So I don't care from a painter's standpoint that this doesn't fit the wavelength of light. I'm going to come up with a color that's going to be a mixture of colors, blending it together, so I have a nice blend that goes back to the red. Okay, so that doesn't map on scientifically, mathematically perfectly for our analogy. However, as a metaphor, that's perfect. That's exactly what we want. Why? Because that actually mirrors exactly what pitch does, right? Because the pitch, as the pitch goes around the circle, if this was going A all the way around and going to an octave, then we're going an octave up, it does, the pitch does repeat itself. So that means we do want, so the color doing that is perfect. That's exactly what we want. It's not exactly scientifically one-to-one mathematically proper. The painter fudged it, flipped it, mirrored it, and then added magenta. But from analogy standpoint, that's perfect. So this color wheel, what we'll do is we'll kind of show you how mathematically we do that in our practice problems. But then we're just going to use the color that's given to us in the color wheel, which is measured by HAS. There's a color system. I forgot what it is exactly, but they already have it mapped out. And that color system has these colors, which are the hues, mapped out to a 360-degree circle already. So it's already done for us, and they've already kind of made this. So we'll actually use that color wheel. Now the problem is, like Excel doesn't use that color system. They typically use an HEX color system. So that's not perfect, because that color system takes into account multiple dimensions, not just hue mapped out on a 360-degree wheel, but also things like brightness and lightness and what do they call it, saturation and whatnot. So they give us these numbers that take into account all these different factors, and therefore the numbers do not map onto a 360 wheel. But what we can do, of course, is simply convert from a 360 color wheel using AI. Just ask AI, I'm looking for this 360 degree color, 60, convert it to the HEX color system. So we'll do that in our practice problem, and then you can derive the color, and we get an absolute color system which maps out perfectly, and then we can get the names of the colors. Now note that these names are somewhat, you can think of maybe arbitrary. I mean, red is red, that's not a problem there. But when you get to like yellow green, then there's a question just artistically, what would you call that? The actual color number should be somewhat exactly what it is, right? Because we got that from a 90 degree on the color wheel and then converted it. But the actual name is going to get muddy when you're looking at colors that are closer together. Now you also might say, well, look, these two colors are pretty close. I'm not sure if my eye can pick that apart. And some people's eyes are better than others, just like some people's ears are better than others. But I do think you can get better at it, right? So meaning just like your ears can get better at picking up pitch, your eyes can get better at distinguishing shades of different colors. So I thought that at first, and then I was like, dude, what? You could totally do that, right? Like, I mean, I could see the difference between those colors if I look at it, particularly if I'm only working with the 12 colors here. Now we're also going to give an absolute name to the colors. I want to memorize the names. So these names become important. Why? Because then I can name, if I'm going from the A note to the B note, I can name that just by color. I'm going from red to yellow, going from the red note to the yellow note. That means A to B. It's not like it's an abstract, arbitrary thing, because red is A, right? And then, okay. Now, one other thing just to note here, you might say, well, you should have started the spectrum on C, because the piano typically starts on C, even though we measure the spectrum from A. We'll discuss that more later. I think the reason I start on A is because I think it's more logically consistent to start on A, because that's where we start the musical alphabet, and that's what most people think of as 440 is the number that comes to most people's minds if they know any number in hertz more than the number for C. So I just think that it makes more sense logically. There's a lot of things on the piano that don't make exact sense musically. I mean, in terms of if it wasn't for the piano, we probably would do it differently, right? And so again, you can debate that, but that's why I chose to start the spectrum from A. Now notice if you can visualize the color wheel, that also gives you a visual idea of where you are, like where, right? Because I can see the distance basically with the color wheel. Okay, so also what we want to do then is see the notes. I want to be able to say red is A, and I want to say A is red. Flashcard time. I want to say spring green is D, and D is spring green. D sharp or E flat is cayenne. Cayenne is D sharp or E flat. All right, so I'd like to do that. And then it's often more practical even to do like a Nashville number system with the colors. Because if you've seen our prior course or section, we've talked about an analogy of we're always working in a 7-note collection generally in Western music. There are 12 sets of 7-note collections, right? 12 7-note collections that we're working in. So the Nashville number system is a way of giving us an absolute number from the perspective of a number for all of the 12 sets of 7 notes. Similarly, we might want to do that with color. In other words, I'm going to take the C this time. Why am I taking C and not A? Because this is an area where I think most people work, right? They work from the C as our practice because it doesn't have any sharps and flats in it, and it's easier to work from. So I'm just going to take that as we do with the Nashville number system, or in a similar fashion at least, and look at the colors related to the key of C if I apply the formula out, meaning C, whole, whole, half, whole, and then it goes back here, whole, half, meaning all the ones that aren't sharps and flats if I start from the key of C. And so that's going to give us this set of colors. Now, if I use that set of colors to name not the notes, but the points of the nodes, the Ionian or Nashville number system, the Dorian, the Phrygian, the Lydian, the Mixolydian, the Aeolian, the Locrian, and I memorize just these 7 colors for what I would call the continents in our color system, those will be the same for all 12 collections of 7 notes, allowing us to visualize the pattern as we move through all 12 sets of collection. I'll show you in a second. So this builds a 1-to-1 map of the 12 notes scale into 12 hues. All right, so this is our fretboard. Now on the fretboard, we're only looking at the points right now. We're not looking at distance. We're not looking at intervals, in other words, or modal distances. We'll talk about that later. But but we're just looking at the points. You can visualize the points two different ways. One is the letter point. It's an A. This is a B. This is a C. The other is the relative position in the collection of notes that we're working in. In this case, we're looking at the 7-note collection for the key of C major, meaning we're looking at the Ionian is a C, which is Nashville number system 1. The Dorian, which is this D, is the 2, or Nashville number system 2. The Phrygian is here. That's going to be sky blue, and so on. So if you look at it that way, that's often the most functional way to look at it. So we're tying the colors in this case to not the note points, but the relative nodal points. Why? Because then if I move forward to the collection of notes, the Ionian is now the C sharp or D flat. You can see this pattern, which I call pattern number 1, or from a caged system, you might call it a G-shaped C major type of pattern. And sometimes you would add this one here, but I want to just keep it simple with these collection of notes right here. And you can see it moves up. Now it still looks quite busy. You're going to say, well, there's a lot of color there. It might kind of throw you off because there's a lot of brightness going at you and you're not used to it. But once you get used to it, it's quite helpful, because now I can see all of the relative positions have moved up, right? I can see this pattern and I can associate all of the relative positions, which is really the important thing we want to do. I can say, well, I'm going from the Aeolian to the Phrygian is from a Nashville number system, the 6 to the 3. I still have the pattern of going from the 6 to the 3. It's going from the red to the sky blue, red to the sky blue.